Now, there is another way to add vectors together, and that is adding vectors by vector resolution. Now, this method can become extremely useful when you have to add more than two vectors together. Because imagine trying to add three vectors by, vector triangle method. You might get something like this, okay? And first of all, you will not even get a triangle. You get some weird quadrilateral, and there might be no amount of geometry that you know that will help you solve it. So this vector triangle method is great for adding two vectors, but it's quite bad when it comes to adding anything more than that. So let's look at a simple example. Suppose I have a point over here and I have three vectors acting on this point. Let's say one goes like this, let's call this x. One goes like this, let's call this y. And one goes like this maybe. Let's call this z. And we want to add all these vectors together. So what you need to do, you need to resolve all these vectors into their components. And so remember, when you want to resolve vectors, you always choose your axis first. So let's be simple and choose the xy axis. Okay, in which case we would probably need this angle. Let's call this theta, and let's call this phi. And so we break all the vectors down into the relevant components. So this would be x cosine theta, and this would be x sine theta. This, on the other hand, would become z sine phi, and we'll have a z cosine phi. Here we don't have to split y because it's already along the axis. And now what we do, okay, once you've resolved the vectors that need to be resolved, you can ignore them, okay, they are not part of the system anymore, okay, and that's what we have. Now, once we have done this, simply add up all the components together. So when we look at what's happening on the x side, okay, we have this and these two, and so the net x vector would be x cosine theta, okay, minus z cosine phi minus y. And of course, the net y vector would be this minus this. So that would be x sine theta minus z sine phi. What you have now is a very simple situation where you have an x that looks like this, okay, a net x vector like this, and a net y vector that looks like that, okay? And then all you need to do is to find the resultant vector like so by using the Pythagoras theorem to find the magnitude of that, okay, which is of course the square root of x squared plus y squared. And you can always find the direction by finding this angle here, okay, where theta equals to tangent inverse y over x. And that's how you add any amount of vectors vectorially.